Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Tiangong space station. So let's dive right into it. Well, first we have to understand China before we understand this space station. Well, China is not allowed in ISS now, which is kind of odd. ISS stands for International Space Station, and more than 10 countries have participated into it. So what's the problem? Well, USA blocked China, and because USA is like a majority stakeholder, they are like, no, whatever we say goes. And the primary reason cited for that was technology transfer to army. Now you have to understand that USA has an army division, so does Russia, so does Canada, so does Japan, so does ESA. Now idea with that is like whatever we are doing in space must be done for betterment of humanity, not trying to blow each other up. And if you want to do technology to blow each other up, it should be in different department. Now that does make sense. And China, like, again, is state-owned system, and like there is zero transparency, so China was blocked based on that. And that's why other countries also supported that. It's like, even though they may be like, that's a bit harsh, but they did support it, otherwise it would not have gone through. So that's on basis of that they stopped China from participating into ISS. However, it worked out legendarily well for China, because that forced China to be independent. And what does that mean? That simply means they became the third country to achieve human space flight. At this point in time, only Soviet Union is the first, USA is second, third is China, and Soviet Union, you can now replace it with Russia. So you get that point. Like, that's a very big deal. At this point in time, there is no other country that has that human space flight, and they already built Tiangong 1, Tiangong 2. They really have to find a better name, because I get it, they love the name Tiangong, heavenly palace, but come on, you already used it 2 times, 1 and 2. So this one is like Tiangong space station. So again, those are prototyping, so those were like single module unit. This is multi-module, they're gonna have multiple modules connected to it. So this is a very big deal for China, because China went from like, hey, could you let me play with you? It's like, no, okay, I'm gonna build my own play school. So that's a good thing from a national pride point of view. That's an awesome thing. So let's understand ISS, because everything you're gonna build in space is gonna be compared with this puppy. Now ISS is reaching basically retirement age. What does that mean? That simply means every component in this puppy is more than 20 years old. Let that sink in. This puppy is 20 years old. That is very old time, especially in technology, so to say. So if you want to do things in here, the outdated technology is a hurdle now. So for example, if you want to, hey, I want to attach this system to attach a fiber optic system to have this kind of communication bandwidth, it's like, yeah, I cannot do that. Like, everything is now every modern research is just like bolting things on top of old aging infrastructure. For example, these solar panels now have been replaced with newer, smaller solar panels. Now you will have very hard time finding photos for that, because like this photo was taken from space shuttle. Space shuttle was like docking like this, so they have very good photos. Like, whenever you see amazing photos of ISS, generally they are from space shuttle, because of the orbit and all that jazz. So that outdated technology is a serious limitation now. It's like, your thermal management system, yeah, it's almost reaching its breaking point. And there is too much red tape. That's also an issue. For example, let's say India is like, hey, we developed this printer, 3D printer, let's just say, and we want to test it in space. Now who has to give approval for that? NASA, awesome. Roscosmonaut, okay. Canada Space Agency, okay. Japanese Space Agency, why? And European Space Agency, really, why? So that's the problem, is like too much red tape is there. Like, and it applies for all of them. And even if all of them are like giving you a go ahead, they're like, hey, yeah, that person is working on that, awesome, we support you, and they actually support you, it will still take you months to just to get the paperwork signed. So that's the problem at this point in time. This puppy is too convoluted. It's like, if you want to do something in space, it's like, okay, let's start building things. You build things, and it's like, okay, now we want to send it to space. That could take upwards of 2-3 years, just because of this many signing works and all that. So red tape is a very serious issue, and technology today moves ludicrously fast. This is not like 1990s technology. Like right now, 2020 technology is like quick iterations. So this is a serious issue with ISS. So Tiangong is built. Again, this does have the advantage, you build it first or you build it better. So they're trying to build it better, and it has 100 kilowatt of solar power, which is equivalent to what ISS has now. So that is very big. Now again, you can see the size comparison, it's very tiny. And how the heck it can achieve that? Because of modern development in solar technology. It's like, it apparently has gallium nitride system, so it's very long life. It's supposed to have 15-year lifespan. Now be very mindful, 15-year lifespan. ISS is already 20 years old. So ISS is not a bad technology. It's like when it was created, it was mind-boggling. It was like, can humans even do this? And they're like, yeah, we can do this. So do not think like in terms of technology, ISS is behind or anything like that. When it was created, it was like way too state of the art and still surviving. So this puppy, even in their design documentation, they are only expecting 10 years of good life, and after that it will directly depend on how much maintenance they are willing to do. If it becomes too expensive, they might just crash it into the sea. And it does have one good technology, that is 4 Hall effect thrusters. Now if you are familiar with Lunar Gateway, they are also planning to test this thing out, because you have to understand, ISS does require what we call station keeping, meaning the velocity delta V starts to go down and they have to add more delta V so they can raise the orbit. Consequence of that is they consume 7 tons of propellant per year. Let that sink in. 7 tons. So China space station, they want to be like, again, of course it's smaller, so they will not consume 7 tons, but they want to make that very small. How? Utilizing ion thrusters, ion engines. Basically Hall effect thrusters should provide them enough juice, and it also saves them. It's like, what the hell are you gonna do with huge solar panels? Because like, again, 100 kilowatt of electrical energy is 100 kilowatt of heat. What the heck you have to do that? So you want to vent it out, and it does not have huge radiators like ISS does. So the best way is just use that to propel your spacecraft if done correctly, because again, at this point in time, this is Gen 1 of testing, so we'll find out soon enough whether this works or not. And it does have normal rockets, so it's not like, okay, if those thrusters fail, it's going to crash. No, thrusters should work out. If it does not work out, they have a normal rocket for backup. And its total weight, if done, should be around 100 ton. And to give you a context, that should be around 420 tons versus 100 tons. Now this puppy will have 110 cubic meters of pressurized volume, basically where you do not need to use spacesuit. What does that translate to? That translates to a small aircraft, basically a aircraft like a twin engine aircraft that has around 200 passenger capacity. And the design is not based on ISS, is more based on 1986 of Mir. Now benefit of that Mir design is very cheap. Like if you want to, like if SpaceX wants to build a space station right now, they will not try to build like ISS. They will try to build it basically like Mir was built, because it's just module attached modularly. That's nothing more than that. Now ISS, you may think it's the same. No, ISS is built around the truss structure. That's the reason why it's so expensive. The truss was built first. Like again, modules were connected, but truss was like backbone. Everything is built around the trusses. So again, it does allow some advantages. You have to understand, this puppy survived for 20 years. So saying this is a bad design, it's like, yeah, it does not fly. It's like a tangibly good design, but does come with consequence that you have to spend boatload of money upfront, and it cannot be done again simply because there is no carrier vehicle that has that kind of capacity. Space shuttle had that. So it should be finished by 2024, and then you're gonna have like at least 3 modules all the time, and then they're gonna have an emergency return vehicle. So that's the whole point of this thing. And they really do not have a good photo of like it's in space. The module 1 is in space right now with astronauts inside them, but good luck finding any good image of that. So what's the mission of this puppy? Well, mission is international cooperation. Basically they want to invite other people. Now again, it's a geopolitical move, obviously, and who wants to join them? Well, Russia wants to join them, because if you are familiar with my videos, I have already talked about Russia-China collaboration to moon mission. So Russia is like, hey, we want to join. Now what about European Union? They also want to join. So these are 2 big boys. If they want to join with China, and China is willing to allow them, so there is no just like how the heck you're gonna dock and all that jazz, like because orbital inclination and all that jazz. Once you have figured those things out, there is a very good chance that you're gonna have actual multi-space, basically international space station. And this time USA would be excluded, or maybe not. Maybe China is like, I'm the bigger man, I'm gonna allow you enter into my space, so to say. And they're gonna offer, like what they're gonna offer to universities, to basically whoever is coming there. What are they offering? They're offering low red tape for R&D in space. Basically at this point in time, ISS is the only completed space station for zero gravity research. When this puppy is complete, they're like, we offer you, and we do not have paperwork that takes like 2 years to pass through. So that's the selling point, so to say, USP, because it's just China's government. If China's government reject it, they're gonna reject you in like first 5 minutes. So you're like, okay, I save my time, I'll look at somewhere else. And if they approve it, they will also approve it in first 5 minutes. And they're gonna have this basically space telescope, which is literally similar to Hubble telescope. However, Hubble is a deep space telescope. It's like almost telephoto lens. This puppy is a wide angle lens. So Zhongtang space station telescope is going to be utilized. Now the unique part about the space station telescope is that it's going to be on exact same orbit as basically the space station. Benefit of that is like once they have to repair it, upgrade it, refine, whatever they have to do, they can basically dock it with space station. Now you're like, okay, what is the benefit of that? Lot of benefit. If they can dock it with space, they could have upwards of 3 or even 4 crew member working on this puppy, and they have the benefit of robotic arms and all that jazz, and they do not need to have an entire space shuttle going there. Space shuttle was the only thing that can touch basically Hubble, because Hubble was in a different orbit. So space shuttle was huge. It had the capacity, it had the people manpower, and it had the robotic arm also, manipulator arm it was called. So that same thing can be achieved by docking it to space, and this allows them to be upgrading this puppy again and again and again as many times as they want to. So, and now you may be like, okay, if attaching it to station allows them so much advantage, why detach it in the first place? Well, there are humans inside, and if you know anything about humans, we move a lot. So this station will be always vibrating. So that's really not good for space observation. So there is a lot of vibration, noise, like physical, mechanical noise. You want to detach it as far as possible. And during repair time, it's downtime. So it's okay. So I really like that idea. That's a very smart approach of that, because your crew capsule does not need to be huge enough to like have the robotic arm and everything. It's like, it's a multi-purpose. And I can easily see they can have like 3-4 telescopes, just orbiting in the same plane, where they can just keep docking one after another, and they can do like, hey, one for optical, one for ultraviolet, one for X-ray. So they can do that. That's amazing thing. And this, because you have to understand, the optics can last forever, practically speaking, and the only thing that gets outdated or destroyed is reaction wheels and computers and sensors. Those things can be upgraded very cheaply if you have access to it. Having space station directly able to dock with this puppy, those access is super easy. So I like that approach. Is really good. So what we can expect in the future? One thing you have to understand, we are going back to competition drive innovation. Many people, like in nuclear physics industry, they flat out say the sole reason we have never achieved fusion is like because instead of competing against each other, we are just sing kumbaya at this point in time, and that's really not good. People are no longer driven as hard they used to be. It's like, so you look at like before 1950s and 1960s and all that jazz, it was like, this milestone in nuclear physics, this milestone, it's like every milestone was very quick to each other, and then it's like, everybody just calm down. It's like, relax, man, chill, man. It's like we are barely any closer to fusion than we were in that. So many people are saying that. Now again, how true is that? We do never know. I need a time machine with a parallel universe to test it out, but that's the reality. And competition does drive innovation. That's, we can always observe that in actual free market thing. It's like Apple would not be as good as it is right now if there was no Samsung, and Samsung would not be as good as it is right now if there was no Apple. So reality is always like that. Competition is always good. And many times, like, people also is USA falling behind? Is USA like dead in the water? Is USA gone? It's like, no, hell no. USA has huge lead in space. Then their lead, you have to understand it, they achieved lunar mission, manned lunar mission in 1969. Let that sink in. It's like we achieved that. Like, we achieved the things that people are still daring to dream. We achieved it. Like the amount of logistical hardware, the amount of basically infrastructure that was built just to achieve that infrastructure, even in its decayed state, is far ahead of any other country. So that's a significant advantage. And you have to understand, the ISS is being retired. That's an absolute thing. It's gonna happen either in 2024 or it's gonna happen in 2028. It's gonna happen. So basically NASA planned for it. So there is an Axiom space, that station, that is under construction right now. It's gonna be docked to the ISS, and this should be beginning operational in 2024. So backup is already kit, and on similar timeline, they should also have lunar gateway. Think of it this way: if lunar gateway is built, this is also built. Basically, America will go from, yeah, we don't have any space station, to we have 2 space stations in 2 different locations, one on moon, one on low earth orbit. Let that sink in. And there is also plan for 3rd space station, which is going to be like low earth orbit, but it's going to be like inflatable modules. So it's going to have large volume, which people are focusing on manufacturing in space. So at this point in time, USA got that cover. Now there could be a basically small gap, like the gap they had when space shuttle was retired. They had 0 human capability. That gap could be there at worst case scenario, but likelihood is 0. They will have at least 1 space station without any issue, and 2 space station if they are lucky, and if they are really good with it, they could have 3 space stations. That's a lot. On top of that, they have 3 human capsule almost done. One of them is Crew Dragon, already ready to go. They're already being used. Then they have Orion capsule, already been built, tested, ready to go. They are only waiting for the rocket. Then you have basically Starliner from Boeing. That's also ready. It's like in final testing and final bug fixing and all that jazz. So of course it's behind schedule and it will take next year. But think of it this way: next year they will have 2 systems. Year after that they will have 3 systems, 3 independent human launching capability with multiple options, meaning they can even swap out rocket. So if the rocket goes boom, they're like, hey, just replace the rocket. If the capsule goes boom, use the different capsule. That's an achievement that no other country can claim. Russia, like, figure out how many systems Russia have for launching people. So that's the whole thing. At this point in time, USA is so far ahead. Yes, they've fallen back the moment space shuttle was grounded in 2011. Their wings were cut, but they are now coming back and they are much stronger than that. On top of it, there is a little thing, you may have seen it, known as SpaceX Starship. So if Starship is ever built, now again, it will be built. I have zero doubts about that. Their timeline, that's the only thing I'm like, lol, that's not gonna happen. 2024 human rating, no, that's not happening. But other than that, of course, they're gonna build it. To give you a context of that, the commercial crew mission should have been finished by 2017. It took 2021. So I do expect time to be delayed, but I do not expect this to fail. I do expect it to be successful. And even if it's not successful for human system, it could be successful enough as just a crew, cargo transport. You already have a Dragon system. You have to understand that, like, USA will already have 3 systems that can go and dock with this, and there is another capsule already in works from that's like has the aerofoil entry system. So this can just send the space station, and then you can send crew utilizing other things, and this alone has 100-ton carrying capacity. Hopefully, let that sink in. This puppy is alone is like, dude, I don't need space station, I am the space station. So space race at this point in time is heating up, and it's really good for everyone, because technological development is like Neil deGrasse Tyson always jokes about it. It's like, you want to make sure that USA goes to Mars, just leak a note from China. It's like, we are secretly planning to go to Mars. It's like, just make sure it's authentic enough. Next year they basically NASA will get as much money as they need, and 2-3 years from now they'll like land on Mars. So reality is, things are looking up. Again, I do understand this aspect of like competition drives innovation rather than like collaboration leading to peace and all that jazz. So let's see what happens in the future. So this was my presentation on Chinese space station. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.